So today we will be looking at the history of the atom. The first learning question is, what were the two competing models for the structure of the atom? So the two recent models for the atom are our focus for today: the plum pudding model and the nuclear model. Secondly, we should be able to answer by the end of this video what observations have given rise to the assumption that the atom is mostly empty space. So what observations indicate that the atom is mostly empty space? And once we've discussed the nuclear model, it should become apparent as to why the atom is considered to be mostly empty space. Okay, so your examiner is expecting you to know these areas regarding the history of the atom. It says that students should be able to describe why the new evidence from the scattering experiment led to a change in the atomic model. So we will go from the first model, the plum pudding model, and we will lead into the nuclear model. And there was an experiment called the gold leaf experiment, which led to the nuclear model coming about in the present time. Now, notice it's saying that you will need to know, in terms of content, the difference between the plum pudding model of the atom and the nuclear model of the atom. So you will need to be able to tell the examiner how you are able to distinguish between the plum pudding model and the nuclear model of the atom. Notice it says that details of experimental work supporting the Bohr model are not required, and details of Chadwick's experimental work are not required. So just be aware of that when you come to revise. Okay, so let's move forward. Now, so I've mentioned briefly something regarding a plum pudding model and a nuclear model. So if we now look at these two models directly, we can see there is a significant structural difference between the plum pudding model and the nuclear model. The plum pudding model was, let's change this. The plum pudding model was the first model. Then via the scattering experiment, we moved over to the nuclear model. Now, as we can see, if we take, so let's focus our attention on the plum pudding model. Essentially, it was said that the plum pudding model stated that atoms were mainly large spheres of positive charge with negative charges dotted around them. So you had a large sphere, as you can see, this large orange peach colored sphere, which is a positive charge, and amongst that positive charge, this large sphere of a positive charge, there were negative charges which were dotted around. Essentially, they were saying that the electrons were spread out in, let's say, in a random manner around this positive sphere. And that was the plum pudding model. And then we come to the nuclear model, a model which we are more familiar with now, where we have a central nucleus with orbiting electrons. But to get to this nuclear model, we have to describe in detail, or we have to describe the scattering experiment that led us to this nuclear model. Okay, so these are the two models. So you may want to pause it here and just quickly put a quick sketch for the plum pudding model with a brief description: large positive sphere with negative charges spaced around the large sphere. Nuclear model, central nucleus with orbiting electrons. So just be aware that you will need to be able to explain the two models by description or identify it via a diagram. Alright, so let's go back to the beginning. All right. Now, so first let's go back in time and let's say we are now at the stage where the plum pudding model of the atom is accepted. Now, an experiment was going to be carried out by scientists to test this theory regarding the plum pudding model. Now, this test, so the test was conducted with alpha particles. Now, the reason I just want to focus on the alpha particle because we need to know the composition of the alpha particle and why it was used for the scattering experiment. So if we were to take an alpha particle, let's first put this down. So the test of the gold leaf experiment was carried out with alpha particles. Now this is important because an alpha particle is said to be a helium nucleus. Okay, so an alpha particle is said to be a helium nucleus. What is a helium nucleus? So let's put some structures in that show a helium nucleus. Okay, that's not good. Let's put another structure there. And let's just assume this is touching. Okay. This is not the best helium nucleus, so what I will do is doing it with circles there, it's not going to be good. So I will just draw it. Okay. And even that didn't turn out great. However, since we have a nucleus, i.e. helium nucleus, you are expecting to find protons and neutrons within the structure, helium nucleus. Now, for this experiment, of the gold leaf experiment, they were using this thing here, an alpha particle, i.e. a helium nucleus, 2 neutrons and 2 protons. So here we have our protons, and here we have our neutrons. So we have protons and neutrons, i.e. the helium nucleus. Now that is a bit messy, so I'm just going to take off the labels. So in your notes, can you just put down that alpha particles, i.e. helium nuclei, were used for the gold leaf experiment. Now, the reason that we're using a helium nucleus is twofold. It has a significant size, and it has a charge. Now, if you were to look at this helium nucleus and I was to ask you, could you tell me the charge on an alpha particle, the overall charge, you should be able to tell me that it is positive. This is because we have 2 protons and 2 neutrons. Neutrons being 0 in charge and protons being positive, the overall charge of the alpha particle is positive. Now this is going to become important later on when we utilize this alpha particle in the gold leaf scattering experiment. Alright, so this is the alpha particle, and this is going to be very important when we utilize the alpha particle in the scattering experiment. Okay, moving on. Now, the experiment was set out to show that the plum pudding model actually was correct. However, the scientists who carried out the experiment, when they looked at the data that they were receiving, quickly realized that the plum pudding model was not possible to sustain that idea of the atom based on the data that they were getting. If you look at this diagram here, the two images here, you can see the top image. Let's put this in a different color. The top image here, oops, it's not there. All right. The top image here, this image here, this is what they were expecting. So this was the expected results, where the alpha particles, represented by the arrows that are going from left to right, this is the image that they were expecting. So they were expecting that if we were to fire our alpha particles, so let's say these are our alpha particles. Now, if we were to accelerate the alpha particles through the plum pudding model, through the atom, we should see this, where the alpha particles do not deflect or deviate from their trajectory, and they pass through the atom in this way. This, if they had collected data in this manner, this would have substantiated the plum pudding model. However, what they were finding was that the data that they were actually getting was what is represented by the lower diagram here, where yes, we do get alpha particles passing straight through as expected. However, these results here, where there is a deflection, a bending of the trajectory, or a complete deflection, this set alarm bells for the scientists who are conducting the experiment, because this shouldn't be occurring. This is indicating something else. And so this was the start of the concept of the nuclear model.